Well, we've been talking about the errors when I use the trapezoid rule to estimate the area under the curve from 0 to 2 of x squared. And there's actually some formulas that we can use to determine what the maximum error is going to be for both the trapezoidal and the Simpsons rule. So first, let's take a look at the trapezoid rule. If f has continuous second derivatives, okay, so I'm talking about the second derivatives, f double prime, on a to b, then the error e is what I'm going to refer to as, just use that term for my error, in approximating the integral from a to b of f of x dx is, and this is simply something you need to memorize, e, the amount of error, will be less than or equal to b minus a cubed over 12n squared times the maximum of the absolute value of the second derivative of x, or of f of x. Over, this maximum is taken over this interval from a to b. Now, there's a couple of different ways you can write this piece right here. Clearly, I could write this as b minus a squared over, let's say, 12n times delta x. Because remember, delta x is b minus a over n. So if I multiply that through, I have b minus a cubed right there, and I have the n squared. So I mean, if you wanted to write it with a delta x, you could. It doesn't really matter. It's the same thing. So here's my formula for finding the maximum error. It won't necessarily tell me what my error really is, but it tell you that whatever your error is, it's no more than this amount that you can calculate. Now, we have a similar situation for Simpsons rule, only this time if f has a continuous fourth derivative over this interval a to b, then the error e, in approximating the integral, e is going to be less than or equal to b minus a to the fifth over 180 n to the fourth times the maximum of the fourth derivative of x, the absolute value fourth derivative of x, over this interval a to b. And again, there's all kinds of ways I could write this. If I really want to fit in a delta x, I could say, how about a delta x squared? That sounds good. If I put in a delta x squared, then what's going to end up being left is b minus a cubed. I'm still going to have 180, but then I'm going to have an n squared, because delta x squared is going to be b minus, b minus a squared over n squared. Well, if I multiply that back through, I'm going to have n to the fourth down here, and I'm going to have b minus a to the fifth up there. So if you really like the delta x stuff, you could write this piece right here like that. I'm not sure what it gains you, but if you feel better about it, then, knock yourself out. Okay, so now that we have it, let's just check to see what our maximum error would be for this function using the trapezoidal. And remember, this is from 0 to 2. Well, the maximum error will be less than or equal to b minus a quantity cubed over 12n squared multiplied by the maximum of the absolute value of f double prime of x over this interval from a to b. So I need to maximize the absolute value of the second derivative over a to b and try to figure out what that maximum value is. Okay, so let's start off with, let's see, f of x equals x squared. That means f prime of x equals 2x. That means f double prime of x equals 2. 2 is a constant function. The maximum is 2. So this right here will be replaced with 2. Now b minus a equals 2 minus 0, which equals 2. And n equals 4. Now, basically, we're done. So I know that whatever my error is, it will be less than or equal to, be no bigger than, see, b minus a was 2, so I'll have 2 cubed divided by 12 times 4 squared times this max, which is 2. Well, man, I'm going to do some simplification here. 2 cubed times 2, that's 2 to the 4th over 12 times 4 squared equals 2 squared squared, which is 2 to the 4th. So that's going to cancel. So my error is going to be no more than 1/12. It could be 1/12 or less than. By less than, I'm talking about 0 to 1/12, absolute value sort of a thing, right? So I know that it could be no more than that. Well, let's see what it actually was. Remember, we found the area to be 11/4. So if I take the absolute value of 11 over 4 minus 8 over 3, because 8 over 3 was the actual, that gives me, what does it give me? It gives me 33 minus 32 divided by 12, common denominator. That's just 1 over 12. So my error was 1 over 12. So in this case, when I use the trapezoid rule on this, I actually got the maximum error based on n equals 4. Obviously, if n changes, then my error is going to change, or the maximum error is going to change. Now, the cool thing about this is I can also say, hey, look, I know what my maximum error I want to allow, so how many intervals should I get? So I can actually use this thing to solve for n. So let's take a look at this case. What I'm going to have is I want my error to be no more than 0.01. That means that 0.01 must be less than or equal to 2 cubed over, see, what was that? That was 12n squared times 2. See, the 2 was a 4 before when I actually found what the error was. What I'm saying is I need to find n to make this a true statement. Well, what that gives me then is that implies that 0.01 is less than or equal to 2 to the 4th 12n squared. That implies that n squared is less than or equal to 2 to the 4th over 12 times 0.01. This is 2 to the 4th, not 24. Let me see. I'm not going to mess around with it. I'm just going to grab a calculator now and approximate it. And when I do, what I get is n squared is going to be less than or equal to 133.33. What that means then is that n is going to be less than or equal to the square root of 133.33. Remember, I want n, not n squared. So I need n to be less than or equal to 11.54. So what that's really telling me is I need n to be 12. If I set n to 12, then I redo the trapezoid error, I would be guaranteed that my error that I'm going to see will be no more than 0.01. So let's see what happens when I apply the Simpsons rule. Simpsons rule says that the error is less than or equal to b minus a to the 5th over 180 n to the 4th times the maximum of the absolute value of the 4th derivative of x over the interval a to b. This interval means the maximum over this interval. So in this case, well, let's start taking derivatives. So I have f of x equals x squared. So f prime of x equals 2x. So f double prime of x equals 2. So f triple prime of x equals 0, which obviously the 4th derivative is also going to be 0. So this component right here is actually going to be 0. That means I don't care what that component is. The error is 0. The error is less than or equal to 0. Well, yeah, we knew that because we nailed it. Remember, the actual answer was 8/3, and that's exactly what we got is 8/3. Now, if my function f of x was something other than a quadratic, and if I had a situation where the absolute value of the fourth derivative of x was greater than 0, then I could have done the exact same thing I did with the trapezoid rule. I could have left n in here, and by specifying an error, I could have gone ahead and solved it for n and said, hey, if I want no more than this error, then I need to do this many subintervals.